All right, let's just jump right into it. Right now, on the very edge of what we know, scientists are grappling with these enormous questions. And I mean questions that shake the very foundation of everything we think is true. We're not talking about small puzzles here. These are like fundamental cracks in our understanding of reality itself. And they cover everything, from the search for alien life all the way to the ultimate fate of the entire cosmos.
And it all really begins with this one simple, kind of haunting question. When we look up at the night sky, everything we know about statistics, about probability, it tells us that sky should be absolutely buzzing with activity. But all we get is silence. So where is everybody?
To really get a feel for how big this problem is, let's just start close to home, in our own backyard. That number you see, up to 400 billion, that's just the estimated number of stars in our Milky Way. In our galaxy, it's just one of trillions out there. When you start thinking about numbers that big, the silence suddenly becomes, well, deafening.
This whole mystery actually has a name, the Fermi paradox, and it was famously brought up by the physicist Enrico Fermi way back in 1950, supposedly just over a casual lunch. He did the quick math in his head and realized, wait a minute, what our logic tells us should be out there and what we actually see, they don't add up at all.
So here's the fundamental conflict, right? On one side, you've got the math. The sheer number of stars means there should be billions of planets that could support life. And a civilization, even with technology not much more advanced than ours, could spread across the whole galaxy in what's, cosmically speaking, a blink of an eye. But then you have the other side, the reality, which is just nothing. No credible signals, no weird artifacts, no giant alien megastructures, just quiet.
So how do you explain it? Well, the theories are all over the place. Some are pretty benign, like the zoo hypothesis, the idea that we're basically in a cosmic nature preserve and they're just watching us. Others are frankly terrifying, like the dark forest theory, which says that shouting your existence into the cosmos is the dumbest, most fatal mistake a species can make. But one of the most powerful ideas is this concept of the great filter, the possibility that there's some incredibly hard, maybe even impossible step between simple life and a star-faring civilization.
But hold on, maybe the silence isn't because no one's out there. Maybe it's just that we haven't been looking in the right way or closely enough. So let's zoom in a bit, from this huge galaxy-spanning paradox to one specific little world where for a moment scientists thought they might have found the very first clue, an exoplanet called K2-18b.
So for a little while, this planet was the absolute center of the astronomical world. First, a team using the amazing James Webb Space Telescope announced they might have detected a gas that is really, really strongly linked to life. And it was this incredible, thrilling moment. But, that's not how science works. It's all about checking and rechecking the work. And sure enough, a follow-up study looked at the exact same data and said, whoa, not so fast. We can't confirm it. And that just shows you how careful and tough this work really is.
So what was all the fuss about? It was this one molecule, dimethyl sulfide, or DMS for short. And the reason scientists got so excited is that here on our planet, almost all of it is made by one thing and one thing only, life. Specifically, tiny little critters in our oceans. So yeah, finding that on another world, that would be an absolutely profound discovery. There's a quote from Sarah Seeger, an astrophysicist at MIT, that just nails the mood perfectly. She said, when it comes to K2-18b, enthusiasm is outpacing evidence. The idea is so exciting, so tantalizing, but the level of proof you need for a claim like that is just immense. In science, you have to be your own biggest critic. And this right here shows you exactly why that skepticism is so crucial. The initial signal they found had what's called a 3 sigma confidence level. Now that means there was about a 0.3% probability that it was just a random fluke. Sounds pretty good, right? But for a discovery of this magnitude, finding alien life, the gold standard in science is 5 sigma. And just look at the difference. That means the probability of it being a random accident is a minuscule 0.00006%. The K2-18b signal was super intriguing for sure, but it just didn't get close to clearing that incredibly high bar.
Okay, so the search for life is pushing our technology to the absolute limit. But it's not the only area where our whole understanding of things is getting a serious stress test. Some of the biggest mysteries are woven into the very fabric of the universe. And for decades, our entire model of the cosmos has depended on one single massive assumption about the force that's pushing everything apart: dark energy.
The idea was always pretty simple, at least on the surface. We thought dark energy was what's called a cosmological constant, an unchanging, steady force that has been speeding up the expansion of the universe at the same rate for billions of years. It was a nice, neat, tidy cornerstone of our standard model of how things work.
But, as this great quote from Willem Albers at Durham University suggests, our instruments are starting to get almost too good for our old theories. We're now making measurements that are so incredibly precise, we're starting to see that this big, strong pillar of cosmology might actually be cracking.
And the crucial new evidence is coming from this instrument called DESI, the Dark Energy Spectroscopic Instrument. It has built the most detailed 3D map of the universe we've ever had. And its data is hinting that dark energy might not be constant at all. In fact, there are clues that it might be evolving, maybe even getting weaker over cosmic time.
This changes everything. It raises this enormous question. If the single most dominant force in the entire universe is changing, then all of our predictions for how it's all going to end, whether it expands forever into a cold big freeze or does something totally different, suddenly they're all up for grabs. Our whole picture of the cosmic endgame is way more uncertain than we thought.
All right, let's pivot. We're going to go from the biggest scale you can imagine, the whole universe, down to the most extreme and bizarre. We're going to a place where our two greatest, most successful theories of physics, general relativity and quantum mechanics, literally go to war with each other. We're talking about black holes.
And at the heart of that war is something called the black hole information paradox. It is one of the deepest, most difficult, most stubborn problems in all of physics. It's a straight-up, head-on collision between our theory of gravity and our theory of the weird, tiny world of subatomic particles.
So here's the conflict in a nutshell. On one side, you have Einstein's theory of general relativity. It's crystal clear. A black hole's event horizon is a one-way door. Once something crosses it, it is gone forever, wiped from the universe. But then you have quantum mechanics, and one of its most fundamental laws is equally clear. Information can never be destroyed. It can get scrambled up, sure, but in principle, it has to be recoverable. They can't both be right. Something has to give.
The person who really brought this whole problem into focus was Stephen Hawking. He figured out that black holes aren't totally black. They slowly leak energy, which we now call Hawking radiation, and over incredible amounts of time, they evaporate away to nothing. The problem is, his original math suggested this radiation was completely random, like thermal static. It contains zero information about what fell in. So if you throw a book into a black hole and that black hole later evaporates, poof. The information in that book seems to be permanently deleted from reality. And quantum mechanics says that is absolutely impossible.
So where does all this leave us? We've got a universe that's totally silent. We've got these tantalizing but unconfirmed hints of life. And we have fundamental cracks appearing in the laws of physics themselves. Let's try to tie all these threads together and come back to that really haunting idea we started with, the Great Filter.
So remember, the Great Filter is some hypothetical, massive hurdle that stops life from becoming a big, galaxy-spanning civilization. And the scary part is, we don't know if it's something in our past that we somehow miraculously managed to survive, or if it's still waiting for us up ahead.
So, could it be that each of these great unanswered questions is actually a piece of that filter? I mean, maybe the cosmic silence just tells us that the leap to intelligence is the barrier, and it's just incredibly rare. Maybe the reason it's so hard to find life is because life itself is the filter. It just almost never happens. Or maybe the real filter is a test of knowledge, that no civilization can truly become interstellar until it solves the fundamental puzzles of its own universe, things like dark energy and quantum gravity.
And that leads us to the final thought, and it's a big one. Does that eerie, cosmic silence mean that we're special? That we've already passed the hardest test and the galaxy is ours for the taking? Or is the silence a warning? Maybe the true Great Filter isn't an asteroid or a supervirus. Maybe the real test is understanding these profound cosmic mysteries before our own limitations, or maybe even our universe's own evolution, closes the window of opportunity for good.